So in this unit, we've been talking about exponential functions, what they are, how to graph them, okay, how to graph transformations of them. Now we're going to look at solving exponential equations. But you need to refresh your mind on a little bit of math before we jump into these. So the first question is, how would you write the number 16 as a power where the base is 4? 4 squared. How about 27 with base 3? 3 cubed. $32 with base 2. 2 to the 5th. These ones you got to be a little careful with. 1/4 base 2. As soon as you see fractions, you should be thinking what kind of exponents? Negative exponents. Not fraction, negative exponents. So 2 to the positive 2 is 4. 2 to the negative 2 is 1/4. And E, 5 to the negative 1. Because 5 to the 1 is 5, so 5 to the negative 1 is 1/5. So you should be familiar with how to do things like that. You should also be familiar with the 3 exponent laws we've been doing for quite a few years. When I multiply 2 powers, what do I do with the exponents? Add them. So x to the n plus n. When I divide, subtract. Oh, and the base stays the same. 1 power raised to another power, multiply or times. So n. Okay? Because we need to remember these skills in order to solve exponential equations. So what's an exponential equation? Well, it's an equation that has powers in it, and there's a variable in one or more of the exponents. So how do we solve these things? First thing we want to do is we want to get the bases on each side of the equation the same. Because if it follows that if the bases are the same, the exponents must equal each other. Okay, so that the exponents on each side of the equation must be equal. So if you get the bases the same, you basically cross out the bases, and then solve what's left. So this first one is pretty straightforward because the bases are the same. I just say, okay, bases are the same, which means the exponents must be the same. Which means x must equal. Right. What about the next one? I have to write them as powers. Can I write them both? Like right now, this has a base of 8. This has a base of 4 because it's the same as 4 to the 1.
2.
2.
To the power of 2 equals.
So, how do I write 4 as a power with base 2? 2 squared. And 8?
2 equals.
2, no, hang on. Remembering that we still have to raise that to the x. That's important. Okay. Well, I can use an exponent law to simplify the right side of the equation. What's an easier way to say this? 2 to the 3x, because when you raise one power to another, you multiply the exponents. Bases are the same, so they can go solve what's left. X equals 2/3. Okay. So these would be more the type of questions that you would see, where you have to change one or more of the other, or one or more of the bases. How about C? Yeah, so I can leave this because I can write 27 as, and then parentheses around it because you're going to be raising it to the 2x. Which means that if I simplify the right-hand side using exponent laws, I get 3 to the 6x. Now I'm ready to equate the bases, or sorry, equate the exponents. So 4x plus 1 equals 6x. I can move the 6x over, get negative 2x plus 1 equals 0. Negative 2x is equal to negative 1, x is out. For D, what I do? This side looks good, but I have to change this side. 5 to the negative 3. You should be able to go from there. Get for x.
Negative 6.
6, right.
Can you show me what's
This one. What do I have to, what are the common bases? 2. Right? Yeah, I can't use 4. I mean, this is 4 squared. But I can't write 8 as base for 4. Okay, so I gotta go to 2. So 8 is the same as 2 to the, and remember, parentheses around it. Write the other exponent. 16 is the same as 2 to the 4th. Parentheses around it because I'm raising it to the x plus 1. To simplify this, whether I use the multiplication exponent law, or sorry, the power of the power exponent law, and I get 9x minus 6, good, equals good. Bases are the same. So now we can go tackle the exponents. So I'm going to take the 4x over here and get 5x minus 6 equals 4. Add 6 to both sides and I get 5x equals 10. Divide both sides by 2 and I get x equals 2. Okay. How about F? Yeah, I gotta go 3s. So 3 cubed to the x plus 3 equals 3 to the negative 2, parentheses, 2x minus 5. And that looks very similar to the previous question. You finish that one off. You should be able to finish that one off. Just remember, when you see questions like this, When you see the numbers 2, 4, 8, 16, 32, you should be thinking base 2. When you see 3, 9, 27, 81, you should be thinking base 3. When you see 4, 16, 64, you should be thinking base 4. 5, 25, 125 is base 5. So we should get 3 to the 3x plus 9 equals 3 to the negative 4x plus 10. Bases go. Solve what's left. Take the minus 4x over here, so it becomes 7x plus 9 equals 10. 7x equals 1. X equals 1/7. I throw in this last one because I've seen it on the provincial. What makes this one a little weird? Yeah, that too. How could I get rid of that too? Yeah. I divide both sides by 2. Now it looks familiar. So if you see a number in front of the power, divide it away. And then you'll be left with ones that we've been working on. So I just have to change 81. 3 to the 8. 4. So x minus 1 equals 4, so x must equal 5. And this last one is just an example where we can use exponential equations and any type of exponential growth, like bacteria or populations or things like that. Okay, we can use exponential equations. So we've got 4 bacteria in a sample. Okay, and we know that the bacterium doubles every hour. How would you write an exponential function that models the sample's growth over time? Well, how much is 1 hour? How much is in there 1 hour? Are we just throwing random numbers out? After 1 hour. 2? Really? That's weird because we start with 4 and yet it goes down.
8.
Yeah, 8. 2?
No, just
Oh, what is it? What'd you say? You are right. I know. Are you okay? Miss Ann Jester, are you okay?
He's going multiply
X
32.
32. So how do I translate that to an expression? It's doubling, but I also have to include, where do I start? How many do I start with? 4, and then I times by 2 to the t. Right? Because if it's 1 hour, it only doubles once. So 4 times 2 is 8. If it's 2 hours, it doubles twice. 4 times 4 is 16. So that's what the expression should look like. So we want to figure out, how long does it take in hours to get to 4,096? Well, how would we solve this? Very similar to the last one we just did. What would you do first? Divide both sides by 4. And 2 to the t is equal to 1024. So now we got to figure out 2 to the 1 is 1024. Well, I always like to start with 16. 2 to the what is 16? 4, right? Okay, 32. 5, 64, 128, 256, 512, 1024. There you go, 10 hours. Or just play around with it on your calculator until you get it right. It doesn't take you long. It wouldn't take you long. Because, I mean, if you tried 2 to the 8th, you'd see that you were a little less, but you were close. So.